Hello viewers, welcome back to Coding Interviews channel. Hope you are doing great. If you haven't subscribed to the channel yet, please go ahead and subscribe. I have created bunch of playlists to cover various categories of problems such as BFS, DFS, dynamic programming, stacks, queues, linked lists and so on. Please check them out. You can find the code for this particular problem to the in GitHub repository, and the link is available in the description of this video below. Let's jump into today's problem. Single number 2. Given a non-empty array of integers, every element appears 3 times except for one, which appears exactly once. Find that single one. So basically we are given with an array, right? So let's take this example array, example 2, right? And in this particular array, all elements appear 3 times, right? So that's what it said, but except one, right? So that's what it is. So here 0 appeared 3 times and 1 also appeared 3 times, and the last one 99, it appeared only once, right? Exactly once. So we need to find out this 99 as the answer. So for this particular thing is 99 answer, right? So if we go and try to find out like how many times each number has occurred, right? All other numbers except this 99 should be appearing like 3 times, right? So we will discuss like few approaches here to solve this particular problem, right? So one simple approach could be like, okay, you sort all the numbers, right? Let's say all the given numbers, you sort them and see the count of each number, each unique number, right? If the count is 3, then you are good. If the count is not 3, then that is your answer, right? So in this particular case, if I sort, right? So sort, the sort will be 0 0 0 1 1 1 and 98, right? Sorry, 99, right? So now you go through the unique numbers, and whenever the count is 3, you reinitialize. So now the count is 3, you reinitialize. So now the count is just 1, right? So in that particular case, you just return as whatever that number which doesn't have the count is equal to 3. So this is one simple way. So what you are doing is, first step is sort, and then the next step is you just sort it out and then try to look for the occurrence of each unique number, right? So you initialize the counter to 1 when you are at the 0th position. As long as the next number is same, you increment the counter, right? So let's say for me, I initialize the count is equal to 0 and index is equal to -1, let's say, right? So now I move the index will be 0, right? And the count will become 1, right? And we keep track of the current element is 0, right? Good. So index becomes 1 and count becomes 2, and my current is still 0, right? So likewise, and index is 2, right? Index is 2, count becomes 3, right? And current is still 0. Now in this step, when index is 3, right? So what will be the count and what will be the current? Current is 1. So the current is changed. Previously current is 0 and current is 1. So at this point in time, you need to check whether the count is 3 or not. If count is 3, you move on. Yes, count is 3. So now you reinitialize the count to 1, right? So likewise, if you move on, right? So there are 3 more steps that we will do, 4, 5, and the count becomes 2, 3, right? Once. So now whenever the index becomes 6 and current is 99, so you check whether count is 3. Yes, it is. So now you initialize to 1. But at the end of the going through all of the elements in the array, right? So your count is at 1. So since the count is at 1, you just return the current element. That's it. But this is like a case where your single occurrence element is appearing at the end. That's the reason why you have to go through all the elements. But what if something like this, right? 99. So 99. Let's say that's what it is. our thing, right? Of course, I'm going to change this, right? So in this particular case, that's not the answer, not to be confused, right? So in this particular case, you will say, okay, 1 occurred here. When you are at 4, count is equal to current is 99, right? Right. So count is what? So the number is changed, right? So in this particular case, count is 1, but the number is changed. That means you are going to return this one, right? That's what the logic that we are going to use, right? So let's go ahead and look at the code for this problem, and then we come back and look at 2 more approaches, right? So sort. So initially I'm going to sort the array, right? And initialize the count to 1 and current is initialized to the first number in the nums. Remember, this nums is already sorted. So now we go through this, exactly the concept that we described. So if the cur is equal to nums of I, you increment. Otherwise, you check whether the count is not equal to 3. If it is equal to 3, you just assign count is equal to 1 and proceed to the next number, right? If it is not equal to 3, you assign the previous number to the cur and break it. So you don't have to go further, and finally you return the cur. So that's how we are able to solve this problem. So what is the time and space complexity for this? Time, space, right? So the first step that we are doing is sorting, right? So any sorting would take order of n log n time, right? So that means where n is the number of elements in nums. So in that particular case, I will say order of n log n is the time, and after that we are going through the elements in the array again. So plus n, right? So in any given case, order of n log n will be bigger than order of n. So we will say, okay, the total time complexity is order of n log n, right? And the space, are we using any space here? We are using only like a couple of variables here. Other than that, we are not using anything. So space, we will say order of 1, that is a constant time complexity, right? So this algorithm is order of n log n time and constant space complexity, right? So that's what it is. And then next, go through the next method, right? So we will call this as approach 1, right? Approach 1, and let's go to the approach 2, right? So here what we are going to really do is we will keep track of the occurrence count for each element, right? So we will create something like, okay, I'm going to consider this array, right? So I'll consider this array. So in this approach, what we are going to do is counts for each of them. So how many times 1 occurred, how many times 0 occurred, how many times 99 occurred, right? So how many times 0 occurred? 3. How many times 1 occurred? 1. How many times 99 occurred? 3, right? So this is our map. This will have all the occurrences of individual elements, right? So now once I generate this map, I will just go through this map and figure out wherever there is single occurrence. I will have to ignore all the 3 occurrences, but just get the single occurrence. That will be our answer, right? So this is a very simple approach. Basically, we are trying to accumulate or count the number of occurrences for each of the unique numbers. Once you have that occurrence map, right? So let's call this as occurrence map, right? So once you have this map available, you go through this map and see where you have 1. That is our answer, right? So that's our second approach. Let's go look at the code for that, right? So you have a map and you go through the array, the list of numbers in the nums, and then if keep on inserting and accumulate the count of each numbers, right? And you return whatever the number that is that's occurrence count is not equal to 3. So we were already said, okay, except one number, all other appears 3 times, and this number is appearing exactly once, right? So that's the reason why I'm just straight away picking up, if the number of occurrences is not equal to 3, just get that, right? That is our answer. Simply that's what I'm doing here, right? So the first key thing is you create the map. So but once you create the map, all you are going to do is search for a key whose value is not equal to 3. That's what we are doing here, whose value is not equal to 3. That is what is our answer, right? So now that is our second approach. So what is the time and space complexity for this? time and space, right? So time, how much time we are using here. So we will say, okay, number of elements in the array, this is order of n, right? So let's say n is the number of elements in the array, and in order to find this element, right, how many times we need to go through the map, assuming all the numbers are appearing 3 times and except 1, right? So we will be going through the map order of n by 3 times, right? Order of n by 3 times. So the totally it will be say, what we will say is order of 4n by 3. That is the time complexity. But if you take out all the constants, right, we will end up saying, okay, it will be order of n time, right? So if you compare between the first approach and second approach, first approach it was order of n log n, and second approach is order of n overall, right? So there is a improvement that you can see, right? And what is the space complexity? The space complexity is we are using a map, right? How many elements this map will have? Order of n by 3, right? Because all elements except 1 will be occurring 3 times. So n by 3, order of n by 3 is what we are saying for the space complexity for this second approach, right? Good. So let's go look at the third approach, right? Approach number 3. Okay. So in approach number 3, what we are going to use is we are going to use some math, right? So we have said all elements except 1 should occur 3 times, right? Right? All elements except 1 should occur 3 times. But let's assume all elements are occurring 3 times, let's say, right? All elements should occur 3 times. This is just assumptions, right? Assume all elements occur 3 times, right? This is our assumption. In that particular case, if we say sum of all elements will be, so let's say sum is sum of all elements, right? Sum is sum of all elements, right? And so we are saying 3 times, right? What if the numbers are occurring only 1 time? What if numbers, all numbers, not just one number, all numbers occur 1 time, right? 1 time. That means the sum will be what? This sum by 3, right? Right, let me call this sums as something else. 3 sum I'll call, right? 3 sum. So it will be 3 sum by 3, isn't it? So we assumed, okay, all the elements are occurring 3 times. So then in that particular case we call that as 3 sum, right? And what if all numbers occur 1 time? We are calling that sum as 3 sum by 3, right? Because it should be exactly by 3, right? So we will use this math formula, right, in order to solve this problem in approach 3. So we were said one thing, only one element did not appear 3 times. That means, so this 3 sum, right, this 3 sum, so I am going to call this as single sum, right, 1 sum, right, 1 sum, right. So 3 sum by 3 should be equal to 1 sum, but in our case, right, in our case one element did not appear 3 times, right, it appeared only 1 time. So what we will say is 3 times of 1 sum, right, 3 times of 1 sum, right, minus the actual sum of elements, right. What does that give you? 3 times of 1 sum means you are taking 1 sum, that means as if each element occurred single time, and you are multiplying that by 3, right. And then what is actual sum of elements? Actual sum of elements is only, you just take the sum of all those elements, and if you divide that, right, if you divide that by 2, that will be our answer, right. That will be our answer. How? Let's say how. Now let's go through this example and try to understand this, right? Okay, now that 3 into 1 sum we said, right? 3 into 1 sum. So how many times each element occurring? Just once, 2 and 3, right? So what will be 1 sum? 1 sum is 5, right? Good. Actual sum is what? Actual sum is what? 2 plus 2 plus 3 plus 2, right? It's 11, right? Good. And what we said is 3 into 1 sum. That means 3 into 5, right? Minus actual sum is what? 11, right? By 2, that's what we said, right? What that is become? 15 minus, is it 15? Actual sum is what? No, it's not 11 actually, it is 9, right? 2 plus 2 plus 3 plus 2. So 2 plus 2 is 4 plus 3, 7 plus 2, 9, right? Yeah. 15 minus 9, right? By 2. So 15 minus 9 is 6. 6 by 2 is 3. 3 is our answer, right? So that's what it is. 3 is our answer, right? So this is a simple approach that we are going to use. Basically, in order to calculate the 1 sum, we need to come up with a technique, right? How can we calculate 1 sum? We will use a hash set, right? We will use a hash set to count only the things which appeared only once, right? So let's go ahead and look at that particular approach, right? Okay, so this one, we used a hash set and we are putting the unique sum and total sum. That's what I am saying. So this unique sum is what? 1 sum I am referring to. This total sum is what? The actual sum I am referring to, right? So I'll go through the entire array, right, and then get the unique sum and total sum, right? So 3 times unique sum minus total sum, right? That's what we said. 3 times unique sum minus total sum by 2. That is our answer. That's it. So here I am using the long as variable type, because if you add so many elements, the range could shift to the long range. Basically, it could go out of the integer range. That's why I am using the long as the sum, which keeps track of the unique sum as well as the total sum, right? So finally, once I do this, I am converting that back to the integer before returning it. So this is a math based approach completely. So let's go ahead and look at the time and space complexity for this, right? Time and space, right? So what is the time? We are going through the entire array once, right? So that means order of n, right? Are we using anything else? Yeah, that's it. I think that is the time. And space, how much space we are using? We are using this, the hash set and these 2 variables. But this hash set, how many elements you are trying to store in the hash set? Obviously n by 3, right? So order of n by 3. So that is the space complexity. So time complexity is the order of n and space complexity is order of n by 3. So we collectively looked at 3 different approaches, and 2 of them are with order of n time complexity and 1 of them is order of n log n. And when we have the order of n log n approach, right, the time space complexity was constant, right? So if you have any further questions, please post them in the comment section below this video. I will get back to you as soon as I can. I have posted this code to the GitHub repository. You can find the link in the description below this video. If you haven't subscribed to the channel yet, please go ahead and subscribe and share among your friends. Please click on the bell icon so that you will be notified about all my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe and goodbye.